In this lesson, we're going to be talking about writing equations of parabolas. I've got 3 examples I would like to go through. The first 2, we're going to be using this 6-step process, and then the last one is going to be a story problem. So in example 1, it says write the equation of the parabola with a vertex at 4, 6 and a directrix at x equals 7. Now, when I'm given this kind of information, my suggestion is always in step 1 to sketch what you're given. And the reason for that is because it's going to usually help you identify what you're missing, as well as the direction that your graph is going to go. And that's going to be very helpful when you're coming up with the equation. Excuse me. So we've got the vertex at 4, 6. And then our directrix at x equals 7, which is a vertical line. So this is our information that's given. And what this tells us right away is that our graph is going to have to be opening to the left. And the reason for that is because, if you remember from the first video, the directrix never touches the parabola. So the vertex has to go left, otherwise it would cross that dotted line. Okay, so we know the direction, it's left, and we know the vertex already, which means that our equation is going to have to be a y-squared equation. So we're going to be using y minus k squared equals 4p times x minus h. Now we have to figure out what our p-value is. And to find p, remember that's the distance from the vertex to the focus or directrix. So since we're given the directrix, all we have to do is count the distance between the two, and that will be our p-value. So if we count from 4 to 7, that's a distance of 3. So p is going to be equal to 3. And now it's all just a matter of filling in our equation. We know our vertex was, here's our h and here's our k, was 4, 6. So we can plug in y minus 6 squared equals 4 times our p-value, which was 3, and then times x minus 4. And remember, the reason I made them -6 and -4 was because my values were positive, so they always change signs. And then to simplify this, we'd write y minus 6 squared equals 12 times x minus 4. And then the last step, step 6, says, is it positive or negative? And all you have to do, and this one is determined basically, is it going left or right, or is it going up or down? So left and down means the equation is negative because it's going towards negative numbers, whereas up and right would be positives. So in this case, because our graph is going left, that means our 12 needs to be a negative. So just put a negative sign in front, and then you are finished. In example 2, similar thing. We're going to follow those same 6 steps. Write the equation of the parabola with a focus at 1, 5. So I'm going to go ahead and sketch that real quick. So there's our focus, and then a directrix at y equals 1. So there's our directrix. So we've gone ahead and done step 1, which was to sketch our graph. Step 2 says to find the vertex and the direction. So if you look at this one, we don't have the vertex, but we can find it because remember, the vertex is always halfway between the focus and the directrix. So if we want to find the vertex, we just count halfway between. So if I have a distance of, let's see, this is a distance of 1, 2, 3, 4. So if I count 2 down, 1, 2 from the focus, there's my vertex. So my point is at 1, 3. And the direction, because my focus is above the directrix, that means my graph is going to be opening up. So now we know the vertex, we know the direction, then we can figure out the equation we need. Because it's going up, we know it's going to be an x squared equation, so x minus h squared equals 4p times y minus k. And now we need to find what p's value is. So remember, p is the distance from the vertex to the focus, which if we count on our graph, that's a distance of 2. So p is equal to 2. And now we can go ahead and plug in everything we need to write our equation. So we're going to have x minus 1 squared equals 4 times 2 times y minus 3. And if I simplify this, we get x minus 1 squared equals 8 times y minus 3. And then remember, our last step, step 6, is to check if the graph is positive or negative. And because it opens up, we're going to leave it as a positive 8. So there is our final answer written in its form. If you have any questions about these examples of writing the equations of the parabolas, please let me know. But as long as you can follow those 6 steps, hopefully it'll be pretty easy to write those. Now the last example is using a story problem, but it's a very similar concept. So we're going to be using the information given to come up with an equation and then answer the piece that they're missing. So it says that you're dealing with the cables of a suspension bridge, and the bridge suspension cables are in the shape of a parabola. And it says the towers that support the bridge, so there's 2 towers here, are 20 meters tall. Okay, so 20-meter tall tower, 20-meter tall tower. And the cables are connected from one side to the other, so they're this parabola shape. And it says that this is on a bridge. Okay, so here's our bridge. And it says that the towers are 80 meters apart. So here's 80 meters. And if it says the center of the cable is 4 meters above the bridge. So if this was our bridge down here, then the center of our cable is here. Okay? And if you want to think of this like a grid, if that's going to be more helpful to you. So here's the road is our x-axis. The y-axis goes right through the middle. So this point here would be at the point 0, 4. Okay, so our center of our parabola is at 0, 4, or our vertex, if you want to consider it that way. Okay, and then the only other pieces that we know about our parabola are the points here and here at the tops of the towers. Okay, so what we know is that from the center of our bridge over to the tower is 40 meters because it's split in half. So this point is at 40, 20. Okay, and then this one would be at negative 40, positive 20. So the reason that's helpful that I'm labeling is because we could use this point to come up with our equation. So what we need is an equation for this parabola here. And then once we have this parabola's equation, what we can do is answer the question in the last part where it says, find how high the cables are 15 meters from the center. So 15 meters from the center is going to be somewhere in here. And we want to know what the height is. So to come up with the height, we have to have an equation. Now we know this is a parabola that is opening up. So we're going to have the equation x minus h squared equals 4p times y minus k. So knowing the general equation is good. We know the center or the vertex is at 0, 4, so we can plug that in. I'm just going to put x squared instead of x minus 0, and then equals 4p times y minus 4. And then we are going to have to figure out what P is. So the problem is we don't know the focus or the directrix. The x-axis or the bridge is not the directrix. So that means we're going to have to use a point from our bridge or from our cable to find what P's value is. And that's where this point here is going to come in handy. So that's an x and a y. So we're going to plug that in to our equation. We're going to get 40 squared equals 4p and then times 20 minus 4. So we can go ahead and do those calculations. So 40 squared is 1600 equals, and then we're gonna have 20 minus 4 is 16. 16 times 4 is 64, so 64p. Now we can go ahead and divide that out. So 1600 divided by 64 is 25. So we have our p value is 25. So now we can rewrite our equation as x squared equals 4 times 25, or that's 100, and then times y minus 4. So now we have our nice equation, and we can use that to answer the goal of this whole problem, which is how high are the cables 15 meters from the center. So what we're going to do is plug in 15 for x to find our y. So 15 squared equals 100 times y minus 4. So we can go ahead and start doing the calculations. 15 squared is 225, and then if I divide by 100, I get 2.25 equals y minus 4. Add 4 to both sides, and I get that the height 15 meters from the center is 6.25 meters. So the goal here was obviously not to come up with the equation, but we needed the equation in order to find our final answer. So use the vertex, use any points on the parabola that are given to you, come up with the equation, and then answer the question at the very end. Now, let me know if you have any questions about this example, but that's it for this part of the lesson.